Okay, let's try to graph now a function, a logarithmic function, the one that you see on your screen, f of x equals to log with base 2 of x plus 1 minus 3. The first thing that we want to do is to review information that this rule gives us. The first thing that we want to know is that the logarithmic functions always have vertical asymptotes. The vertical asymptotes can be solved if you solve the argument of the logarithmic function right here, x plus 1. So the number that is a 0 for this function right here is going to be the number that gives us the vertical asymptote. So the vertical asymptote in this case is going to be x equals to negative 1. How do we graph this function? Okay, the first and simplest way is by creating a table of values. I have done this for you and I have calculated the corresponding f of x for each one of the numbers that you see on the first column. Negative 1/2, 0, 1, 3, 7 and 15. Now these numbers right here may seem strange, but basically these numbers right here are numbers that if you plug them in the x plus 1 argument of the logarithm, they will give you a perfect power of the number 2. So if you get negative 1/2 in here, then x negative 1/2 plus 1 will be 1/2, and 1/2 can be written as 2 to the negative 1. Why? Let me remind you right here that if you have any negative power, let's say 2 to the negative 1, then by using the rules of powers, this is going to be equal to 1 over 2 to the first. What we do is that we consider the negative exponent and we rewrite the power as a fraction, where at the numerator you have the number 1 and at the denominator you have the same power with a positive exponent. That is nothing else than the 1/2. So basically what you have right here is log of the 1/2, that is log of 2 to the negative 1, and since the log is nothing else than the power, the result of that is going to be negative 1. Negative 1, negative 3 is equal to negative 4, and this will give us the point negative 1/2, comma, negative 4. In the same way, if you enter the number 0 in your logarithm, then you have the log of 1. The log of 1 right here is going to be equal to 0, because log of 1 is always 0 no matter what the base is. So you have 0 minus 3 is negative 3. In the same way, I found all the rest of the numbers here, and I produce the points that you see on your screen right here. So the next step that I want to do is to graph all these points together on a graph. Let's do it. So as you can see right here, I have graphed each one of those points on my graph. So 1 comma negative 2 is going to be the point 1 right here, negative 2. 3 comma negative 1, 7 comma 0, 15 comma 1, 0 comma negative 3, and negative 1/2 comma negative 4. Okay, so these are the points, and if you observe these points, you will see that they give me a function, a curve. They seem to be on a curve, and this curve tends to come from the negative infinity from down here. We don't know if this curve converges anywhere. So what I will do now is I'm going to graph the actual function for you, log with base 2 of the x plus 1, and I subtract from here the number 3. So the green curve that you see is the graph of our function. And as you can see, it passes through each one of the points that you see on your screen, the ones that we found from our table. Okay, good. And we also see that it converges. If you pay attention where this converges, you will see that this is the line, the vertical line that you see right here is x equals to -1. And this is the vertical asymptote that we found from our function. So this is the graph. This is the graph that we obtain if we graph all the points from our table and we connect them together on one curve. Writing down what is your vertical asymptote right here, it is extremely important for your graph. So x equals to -1 should always be in your graph. Not x equals to -1, but the vertical asymptote that you get from the rule should always be in your graph.